Hello students. Today we'll talk about concept of capacitance and capacitor. We'll see different types of capacitor. We'll see how to make capacitor and what it does. So let us start. Consider a spherical conductor and we want to deposit charge on it. So we come with our first charge from very large distance, maybe infinity, and we deposit charge on the conductor. How much work we need to do? Now, as there is no charge initially on the sphere, so work done to deposit charge is zero, and hence I can say potential is zero, isn't it? But what will happen if I try to deposit second charge? Now, as previously sitting charge will offer me some repulsion, and hence my work done for second charge will not be zero. There will be some work done, non-zero. But what about the third charge? So as I deposit third charge, potential will still be more. So I can say that as I keep on depositing charge, potential keeps on increasing. So for less amount of charge, I am spending less energy, so less potential. I am starting with zero initial potential. Initial potential is zero, and then as I keep on depositing charge, the potential keeps on increasing. So I can say that Q is proportional to V, isn't it? And that continues as long as you keep depositing charge. As charge increases, potential of the charges increase because repulsion is going to increase, and hence if you want to deposit more charge, you will have to face more repulsion, you will have to spend more energy, and potential increases. And there will be a point uh, where the sphere will refuse taking charge. So if you deposit some charge from one side, other charge will be kicked out. You will see spark because there will be dielectric breakdown here in the surrounding, and this charge will go out. And then you can say that there is limit for this conductor, and beyond the limit it cannot hold charge. That limit is called capacitance of this conductor, and then you can say that this conductor is behaving as charge storage device. Okay, such charge storage device is called capacitor. And how much is the capacitance of this conductor? It is Q is equal to CV, and then I can say that C is equal to Q by V. So this C is called capacitance of the capacitor, and more the charge holding capacity, more the capacitance. And if you see that by depositing some amount of charge, the potential increases too much, then we say that it will not be able to hold too much charge. Capacitance of this capacitor is less. Now, in this case, as we can see, if I want to increase charge holding capacity, what I have to do? What I have to do? The only option I am left with is to increase area. So I can say that for this capacitor, which is called spherical capacitor, for spherical capacitor, capacitance C depends on the area of the sphere. But what if I want to deposit more charge? Do I have any other option other than increasing area? Uh, Let us see that. Now, instead of spherical conductor, let us consider a plate on which we wish to deposit charge. Say I want to deposit so much of negative charge, and what will happen as I deposit charge on it? Uh, as we deposit more and more negative charge, there will be repulsion and potential will keep on increasing, isn't it? And what is the problem if V increases? If potential increases, the problem is that C is directly proportional to uh, 1 by V. More the V, less the capacitance, and then if I want to deposit more charge on this plate, I'll not be able to do that. And then what to do? As we saw earlier, one option is to increase area. More the area, more the charge holding capacity. But what if I don't want to increase area and yet I want to deposit more charge? Then in this case we have one more option. The other option is have one more plate close to it and connect it to ground. What is the advantage? Advantage is looking at the negative charge of this plate, the other plate will acquire positive charge from the ground, and gradually you will have so much of positive charge on the plate facing negative charge. And what is the result? Result is these two are having attractive force between them, and then gradually potential of this plate which is holding negative charge on which we want to deposit more charge will gradually decrease. And what if potential decreases? You can deposit more charge. So normally capacitor is a combination of two conductors which are separated by some distance. And between the two conductors you can have vacuum, you can have air, you can have some other insulating or dielectric material, and there are effects of this material also, which we'll talk about in detail later on. But for now, you can say that capacitor is a charge holding device, and capacitor may be a single conductor of any arbitrary shape, or else it may be combination of two conductors separated by some distance. There are so many different types of capacitors available, and we need different capacitors in different applications. Sometimes we are dealing with very high voltage, so we need capacitor which can hold, which can tolerate very high voltage. Sometimes we look for capacitor which can be charged very fast, like in case of mobile. Nowadays we are looking for fast charging mobile, so there we use capacitor which can be charged very fast, and which decays, which delivers charge at slow rate. There are supercapacitors. So these are some of the capacitors shown here. Now, based on the material between two conductors, capacitors are mainly classified as non-polarized capacitor and polarized capacitor. Non-polarized capacitors are capacitors where between two conductors we choose medium which is not having polar molecules, which is having non-polar molecules. On the other hand, you can always choose material which is polar dielectric between two plates of capacitor, and each one is having its own advantages and disadvantages. We will not get into detail of that, but this is just to give you brief idea about types of capacitor. And of course, we can classify capacitor based on their shape, like the one which we discussed was having two plates parallel to each other, so it is called parallel plate capacitor. But you can always have a cylindrical capacitor, you can have spherical capacitor, and each one is having its own advantages and disadvantages. So let us conclude now. So now we can say that capacitor is a charge storage device. It is simple conductor of any arbitrary shape, and any conductor which can hold charge can be considered as capacitor. But normally capacitor is having two conductors separated by some distance, and the two conductors may be like two parallel plates or maybe two concentric cylinder. So you can have different types of capacitor, but C is equal to Q by V is the equation which is applicable for all types of capacitor. For individual capacitor, like for a parallel plate capacitor, you may have another expression for C. But Q by V is something which you can apply for any type of capacitor, because more the charge, more the potential, and proportionality constant is capacitance. Capacitance of any capacitor is measured in terms of farad, but farad is too large unit, so most of the time all the capacitors which we use are having their capacity in terms of microfarad. Capacitors may be classified based on their shape or based on the material which we choose to place between the two conductors. So this is all we need to know at this point about capacitors. Thank you.